Hello dear students, welcome back. Today we are going to take up a new chapter of our book, chapter number 2, acids, bases and salt. So in this chapter we are going to learn about the properties of these three substances. Acids are the ones which used to have sour taste, while the bases are the substances which have a bitter taste. The salts are the ionic compounds which are formed during the neutralization reaction between an acid and a base. So regarding these three things we are going to learn in this chapter. Like in the previous chapter, we are going to divide this chapter also into different parts. So today, let us take up the first part of this chapter. So at the starting, let us try to learn about the physical properties of these acids and bases. Now, let us see some of the physical properties of acids. The first and the most common characteristic of an acid is that they have sour taste. But all the time, we cannot taste the acids or we cannot taste the object to identify whether it's an acid or not, because many of the strong acids, there are many strong acids which are very corrosive. So if we try to taste an object to identify whether it's an acid or not, that may be harmful to us. Because of that, we cannot always taste an object to identify whether it's an acid. Due to that reason, we use certain type of objects, certain type of substances, which we call them as the indicators. Indicators are the substance which may change their color or which may change their smell when they come in contact with either an acid or a base. So we will discuss about the indicators later in details. Now let us go through the other common characteristic of these acids. The next one is change the color of litmus solution into red. Litmus, actually, it is an indicator which used to be in purple color. The litmus is found in two different forms, in the form of a solution or in the form of a paper strip. The solution of litmus used to have a purple color. So when these acids, when any type of acids are mixed with the purple color litmus solution, the color of the solution changes to red in color. In case of the paper strip, the litmus used to be of two types. One is red litmus paper and another one is blue litmus paper. When we use red litmus paper to test whether an object is an acid or not, if the object turns out to be an acid, then there is no change in the color of the red litmus paper. But if we use the blue litmus paper, if we dip the blue litmus paper in an acid, then the color of the blue litmus paper changes into red color. Now let's come to the next point. Does it change the color of phenolphthalein? Phenolphthalein is also another type of indicator which is colorless. It is also in the form of a liquid. So when we mix a few drops of an acid to the phenolphthalein solution, the phenolphthalein solution doesn't change its color and remain as a colorless solution. Next, changes the color of methyl orange solution to red. Methyl orange is also another type of indicator. This methyl orange, as the name suggests, it is orange in color. So when a few drops of an acid is mixed with the methyl orange, then the orange color solution of this methyl orange will change into red color. Next one, does it affect the color of olfactory indicators? Olfactory indicators are the type of indicators which used to change their smell. Instead of changing the color, they used to change their smell to identify whether an object is an acid or a base. So the olfactory indicators, the smell of them are not affected when we mix those olfactory indicators with the acids. They still used to produce the smell that they already have. The last one is, does it affect the color of turmeric solution? Turmeric, as we know, it is yellowish in color. If we mix some amount of turmeric powder or the crushed turmeric with some amount of water, then we can get the turmeric solution. So when this turmeric solution is mixed with an acid, the color of the turmeric solution remains unchanged, means it used to remain as a yellow color itself. So turmeric is one of the most common substances that we use in our home, and this can be used as an indicator also. So these are some of the physical properties of acids. Now let us see some of the common physical properties of bases. Bases are bitter in taste and they are slippery to touch. So even if they are bitter in taste and slippery to touch, we should not taste whether an object is a base or not by the help of their taste or by touching it. Because there are many strong bases which are corrosive in nature and which are harmful to us. So when we touch those objects or when we try to taste, by putting small amount of this substance in our mouth, it may corrode or it may damage the body part which come in contact with those substances. Because of this reason, we should not taste or try to touch an object to taste whether it's a base or not. So strong bases are highly corrosive. Now, so like what we have done in case of the acid, in order to taste whether an object is a base or not, instead of touching or instead of testing that, we have to use the indicators. So we can use both the normal indicators or the olfactory indicator to taste whether an object is a base or not. So let us see some other physical properties of this bases. It changes the color of litmus solution to blue. So as discussed before, the litmus solution is purple color solution. So this purple color solution, when it is mixed with a base, the color of the solution used to change to the blue color. So this is about the litmus solution. So if we use litmus paper, if we use the red litmus paper to taste whether an object is a base or not, and if the object turns out to be a base, then the color of the red litmus paper changes to blue color. But it doesn't have any effect on the blue litmus paper. The blue litmus paper remains as blue color itself. So now let's come to the next one. Changes the color of phenolphthalein solution to pink. Phenolphthalein is a colorless solution. So in a small amount of phenolphthalein solution, if we put a few drops of base, then the colorless phenolphthalein solution will change into pink color. Next one. Changes the color of methyl orange to yellow. So methyl orange, as discussed before, it is an orange color indicator, a solution. So in this orange color solution of methyl orange, if we put a few drops of base, then the color changes into yellow color. Now, let's come to the next one. When mixed with olfactory indicators, the smell of the indicator vanishes. So, the olfactory indicators, as discussed before, they are the substances which changes their smell. So, when the olfactory indicators, for example, like onion, like cloves, they have a strong smell. So when this onion or cloves, which can be used as olfactory indicators, when they are mixed with some amount of base, the smell of those indicators vanishes, which was not in case of the acid. The acid doesn't vanish the smell of the olfactory indicators. Now let's come to the last point. Changes the color of the turmeric solution to reddish color. The turmeric solution, which is yellowish in color, when it is mixed with the base, any type of base, then the color of the turmeric solution changes to reddish color. So these are some of the physical properties of bases. Now let's come to the indicators. Indicators are the substances which changes their smell or which changes their color when they are mixed with either an acid or a base. There are different types of indicators that are present in the surrounding and that we use to identify whether a substance is an acid or a base. Some of the indicators are obtained from the natural source. It may be plants or it may be any other. Some of the most common natural indicators that are present or that we use are litmus. It is often from a type of plant which we call it as lichen. Another one is turmeric, which is very familiar with us, and the other one is color petals of flowers. Some flowers are there which used to have a colorful petals. The extract of these petals can be used as an indicator, like that of the China rose. The colorful petal of the China rose, when it is crushed and mixed with some amount of water, then that extract can be used as an indicator, and it used to change its color when it is mixed with either acid or a base. There are some other indicators. Instead of changing their color, they used to change their smell. Those type of indicators which used to change their smell in order to detect whether a substance is an acid or a base, they are known as olfactory indicators. Some of the common olfactory indicators are onion, cloves, vanilla. So these are some of the common olfactory indicators that we use. But one thing is that the olfactory indicators can be used in order to detect whether a substance is a base or not, because the base used to vanish the smell of these olfactory indicators. But the olfactory indicators, when they are mixed with acid, there is no change in the smell of these substances. So these olfactory indicators can be used to test whether a substance is a base, but they cannot be used for testing whether a substance is an acid. So these are some of the important things about the indicators. Now, let us come to the chemical properties of acids and bases. The first chemical properties that we are going to discuss is about the reaction of an acid or a base with any type of metals. So, when an acid reacts with a metal, then it used to produce a substance called salt and hydrogen gas. So this is the general representation of a reaction between an acid and a metal. Now, let us discuss this by taking an example. Here, let's take hydrochloric acid and a metal, iron. So when hydrochloric acid reacts with iron, then it forms iron chloride and hydrogen gas. So as told before when we were discussing in chapter number 1, when you try to give an example in the form of a chemical equation, the equation should be in the form of a balanced chemical equation. So in order to balance it, I am going to put 2 here. So here, an acid reacts with a metal, then it forms salt and hydrogen gas. So this is one example of the reaction between an acid and a metal. Now let's see how the bases used to react with metal. Generally, bases doesn't react with metal, but some strong bases react with highly reactive metals to form a complex salt and hydrogen gas. So let us see the general equation and let us discuss by taking an example. So here, when a strong base is reacted with reactive metals, it forms complex salt and hydrogen. Complex salts are a type of salt which contain more than one metallic part. So now let us discuss an example. Here, sodium hydroxide is a very strong base and zinc is a reactive metal. So when sodium hydroxide and zinc is reacted, it forms a complex salt known as sodium zincate. Along with that, there is a production of hydrogen gas. So one common thing between the reaction of an acid with a metal and reaction of a base with a metal is that there is a production of hydrogen gas. So this is about the first type of chemical properties about the acid and the base. Now let's come to the next one. So the next property that we are going to discuss is about reaction between metal carbonate or metal hydrogen carbonate with acids. This metal carbonate and metal hydrogen carbonate, they are basic in nature. Because of that, they doesn't react with a base. They can react with only an acid. This metal hydrogen carbonate, we also call them as metal bicarbonate. So now let us discuss about the reaction between these two substances with the acid by taking the general reaction as well as by taking an example. When a metal carbonate or a metal hydrogen carbonate is reacted with an acid, then it forms salt, water and carbon dioxide. So let us see the reaction between this metal carbonate and acid as well as metal hydrogen carbonate with acid by taking an example each. The first example is about the reaction between metal carbonate and acid. Here, the metal carbonate that is taken, that is used in this reaction is sodium carbonate. This sodium carbonate, when reacted with hydrochloric acid, it forms sodium chloride, water and carbon dioxide. Sodium chloride is a salt. So here, in this reaction, there is a formation of a salt, water and carbon dioxide. Now let us see the second example. The second example is an example of the reaction between metal hydrogen carbonate and acid. Here, the metal hydrogen carbonate that I have taken here, it is sodium hydrogen carbonate. It is reacted with hydrochloric acid. During this reaction, there is a formation of a salt, that is sodium chloride. Along with that, water and carbon dioxide are also produced. So this is about the second chemical properties, that is the reaction of methyl carbonate or a methyl hydrogen carbonate with acid. Now let us come to the next property. The next property is about the reaction between an acid and a base. When an acid and a base reacts, it forms salt and water. This reaction is also known as neutralization reaction. It is because when an acid and a base reacts together, it used to reduces or it used to neutralize the strength of one another, forming a salt and water. Because of this reason, the reaction between an acid and a base is considered as a neutralization reaction. Now, let us take up an example of the reaction between an acid and a base. Here, let us take hydrochloric acid as an acid, and for the base, let us take sodium hydroxide. When these two are reacted, it forms sodium chloride, which is a salt. Along with that, there is a formation of water. So whenever we react an acid and a base, there is formation of salt and water all the time. Depending upon the strength of the acid and the base, the nature of the salt also used to be. If we react a strong acid with a weak base, then the salt that will be formed turns out to be acidic in nature. If the strength between the acid and the base are equal, then it forms a neutral salt. But if we react a weak acid with a strong base, then the salt formed will be basic in nature. So the nature of the salt that is formed during a neutralization reaction depends upon the strength of the acid and the base that is used. So now let's come to the next reaction. The next property is about the reaction between metallic oxide and an acid. Metallic oxides are the substances that are formed when a metal reacts with the oxygen. These metallic oxides are basic in nature. Because of that, they can react with an acid, but they are not able to react with a base. So now, let us see by taking an example. So as the metallic oxide is basic in nature, when they react with an acid, the reaction will be similar with that of the neutralization reaction. So when a metallic oxide reacts with an acid, it forms salt and water. So let us see the example here. For metallic oxide, I have taken magnesium oxide. This magnesium oxide, when reacted with hydrochloric acid, it forms magnesium chloride. Along with that, there is a formation of water. So the reaction between metallic oxide and acid is similar to that of the neutralization reaction. So now, let us come to the last chemical properties. The last chemical property is about the reaction between a non-metallic oxide with a base. Non-metallic oxides are the substances which are formed by mixing a non-metal with that of the oxygen. So these non-metallic oxides, they are acidic in nature. Because of that, they are able to react with the base, but they cannot react with an acid. So the reaction between non-metallic oxide with that of the base is also similar with that of the neutralization reaction. So when the non-metallic oxide is reacted with a base, there will be formation of salt and that of the water. So now let us see by taking an example. So now let us see the example. Here, sodium hydroxide is the base that is taken here. Carbon dioxide is the non-metallic oxide. When these two are reacted, it forms a salt which is known as sodium carbonate. Along with that, water is formed. So this is about the reaction between non-metallic oxide and a base. So these are the things that we studied today. So in the next video class, we will come across the remaining part of this chapter. So for today, let us wind up here. Dear students, thank you.